So first of all, what is generics? Generics is actually a way of creating a template for code reusability. So when I mean code reusability, you want to reduce the amount of code that you write. You want to make an application as lightweight as possible. So you don't have to keep writing bunch of classes when you can actually have one class to replicate um, any other class or features you want to add into your application. Now, most programmers have been talking about generics and generics collections. Maybe they are the same. First of all, generics and generics collection are not the same. Okay, so generics is actually a logic, okay, a pattern, and generics collection is the implementation of that logic. So, without further ado, let's get into the code itself. So let's assume that we have a class. Let me see, um, a class that actually compare details. Want to compare maybe numbers or want to compare price of goods or something, whatever. So compare details. Let's give the class name a compare details class. Okay. So secondly, we will need to have a method in the class, right? Public bool check details. In the check details, let's assume we want to compare um, price of goods. So we're saying something like integer price 1 and int price 2, right? Okay, so if price 1 equal to price 2, okay, return true. Return true. But before I return true, let's just put a word there. Uh, I mean a statement rather. Console the right line. They are the same, right? And if it's not, else it should return false, right? They are different. Okay, just follow the logic and see what I'm trying to achieve here. Return false. Okay, now we have a class that compares details. So here we are trying to compare details, right? Details of price. So if we go here and execute that class, compare details, come equal to, okay, instantiate the class itself. Then let's call the method check details. So we are trying to check details of two prices. Let's assume the first price is 40, second price is 35. Of course, they are not the same. So you will definitely print out the second line, right? That they are not the same. Okay, let's read that. So if we run this, it will tell us that 40 and 35 are not the same, right? So that's what we should see. So it says they are different, false. But if I put 40 here, obviously it will tell me that they are the same, right? So that shows that that is working. They are the same, true. Okay, perfect. So what we are trying to achieve here is that what if I I'm trying to compare, I don't want to compare number, I want to compare names, maybe John and James. Okay, I'm trying to compare names. Look at what it's telling me. It says that cannot convert string to integer because we have integer type here. So that means the type here is strongly typed. It means that whatever parameter is coming into this method must only be an integer. But then I want a more generic parameter, something that can accept any data type, not just integer. What can I do here? Even if I change this to string, it will work. It will work, but then this has become a strongly typed string. It can only accept string too. So it will work here. But then what if I want to do this? I want to change this to integer. So there's issue, right? I have to keep changing my code here all the time, changing my type here all the time. Well, nobody has time to do that, and that's going to clog up a lot of code in the application. And that is where generics comes in. So generics allows you to use any data type in the parameter here or in a class level. Any data type will work. So let's assume that while creating the class, I'm using the generics concept. Then I use the angular close and open angular brackets, and then I can just assume let me put any data type. So the moment I put any data type here, then here I wouldn't use string or int. I would just use any data type. Here as well, any data type, right? Okay, so here I can just change this to price1 dot equals price2. Okay, so that way it can compare anything, even an object. Okay, it becomes a reference type. Okay, so now if I come here and instantiate the class, let me clear all of this first. So let me instantiate the class compare details. So the moment you see this, you see the angular bracket showing here, it shows that it's a generic type. You can see class generics dot compare details. So it shows that it's a generic type. So generic compare details, then I can put my own type that I want to use, maybe integer. Okay, com1 equal to new equal to new. Okay, so now I've told the compiler that okay, this particular instantiation, this particular object that I'm creating is going to be an integer data type, right? Okay, then let's say com1 dot check details, then I can put my integer there, 40, 35, right? Console the right line there and put that. So I've informed the compiler, the framework itself, that this object I'm creating is going to be an integer data type, right? So what if I want to create something like a string? I can go ahead and instantiate it again. Let me call this com2. And I will tell the compiler in the generic angular bracket that this is going to be a string. Okay, this is going to be a string. Then I can write it out here. Okay, com2 dot check details, and if you check now, it's accepting a string. You can see it's accepting a string, right? Here it's accepting an integer, here it's accepting a string. So I can put in my string there. Let me say John and James. Okay, so I can run that and to tell me that these are not the same. Let me try John and John here so you can show me that they are the same. So I'm expecting these are not the same and these are the same, right? Let's run that and see how it works. So we see that 40 and 35, they are different, right? Then John and John, they are the same, right? So that is generics. That is the concept of generics. So I created this class here as a generic class with no special type. So by the time I want to consume that class anywhere, I don't need to be creating another class that we create a string type. I don't need to keep creating it. All I just need to put my type in the generics here. Anytime I want to instantiate the class, we just put my type. So that shortens my code. I'm having one class, just one class, do everything. The only thing I need to do is to tell the generic type that okay, it's going to be this data type. I can even make it an object data type, like a student data type or something like that. But we'll look more into that when we are working on generics collection. And then this any data type. So now we can actually shorten this and just put T there. It shows that type. Then here we can just use T. We can just use T here too. The T represents that type, right? So that's the popular symbol for generics in C#. So it doesn't change anything. If you run it, you still have the same, you still have the same result. So that's the concept of generics, and that's how generics works. You create a class and you put a type there, and then you can keep implementing your your methods in there, and that is how it works. So you have only one class doing everything. You can change the types in the consuming methods or in the gateway methods regardless. So you might be in a web forms or MVC or anything. So if you like this video, click like, subscribe.